Good evening, everyone. I am so glad you are all here today. I am excited to dive into a fascinating topic in physics, that is projectile motion. Before we get started, I want to share a quick story. Like you can think about a cricket match. Yes, when the batsman hits a ball, right? When the batsman hits the ball, it does not just fly in a straight line. Yes, you may see that. Yes, already you may know about the cricket match. Yes. So when the batsman hits that ball, it does not fly in a straight line. It follows a beautiful curved path before it comes down. Yes. So it follows a beautiful curved path before it comes down. That path is an example of projectile motion. Okay, is it clear? So that path is an example of projectile motion. Today we are going to learn about the physics behind that curve and how it applies to so many things around us. Okay. So I encourage you all to participate actively and ask many questions. Okay, right. So to get our brains warmed up, we are going to start with a quick three question quiz to test our previous knowledge. Okay, so I will share screen. So only three questions. Now you can see your screen like that. Okay. So, first question. What is the unit of acceleration in the SI system? If you know the answer, you can unmute yourself and tell that answer, or you can type in the chat box. Already you may know that. Yes. So, what is the unit of acceleration in the SI system? Already you know about acceleration. SI system. Yes. One response. Very good. Good. Any other schools, students, please? One response. Very good. Good. Keep it up. Any other? What is a unit of acceleration in the SI system? Meter per second. M by S means meter per second. Kg per M, kilogram per meter. Meter per second square. And N for Newton. Yes. Okay. Good. So, meter per second square is the unit of acceleration in the SI system. So we can, yes, another one response. Yes, correct. Good. So we can choose that third option. Meter per second square. Great. Correct. Very good. Good. Then next question. What is the displacement of an object moving with a constant velocity of 5 meter per second for 10 seconds in a straight line? So you have to calculate that displacement of an object. So that object moving with a constant velocity. So the velocity value 5 meter per second. So it travels for a 10 seconds. Okay. In a straight line. So what is the answer? 0 meter or 50 meter or 25 meter or 10 meter. Any other response? Yes, someone respond. Okay, one respond. Okay. Any other schools? Any other students? Very good. One response came. The next, please just look at that sum, velocity value, time value. So displacement. Already you know that the formula for displacement. Yes. Velocity is equal to displacement by time. Then displacement equal to velocity into time. Yes, velocity into time. So here velocity 5 meter per second into time 10. So 5 into 10, 50 meter. Yes, very good. Good. So 50 meter. Yes, second option. Yes, correct. We can choose second option. 50 meter. Very good, very good. Then final one question. If an object moves with a constant velocity, what is its acceleration? Already you know that acceleration and the time, constant velocity. Yes, speed, velocity, and constant velocity, uniform velocity. Already you know that terms. So here, that one object moves with constant velocity. Then what is its acceleration? 2, 2, 2. Yes, many response changes with time are 0 or 9.8 meter per second square. Constant but not zero. Okay, good. So correct answer. So the object moves with a constant velocity. What is acceleration? So as if one object moves with the acceleration, then that object velocity have to should be changed. Yes, should change. So constant velocity means velocity does not change. So velocity does not change means it is no what? If the object velocity does not change, what? Yes, there is no acceleration. Yes, there is no acceleration. So if the object moves with the constant velocity, then acceleration, second option, very good, zero. Okay, good, good, good. Okay, right. Okay, so let's dive into a projectile motion. So it is the motion of of an object like ball, okay, thrown or launched under gravity, under gravity with no other forces acting on it. Okay, no other forces acting on it. So there is no air resistance also. Okay, already you know that air resistance always in there, but here we have to consider there is no air resistance for now. So what does the mean of a projectile motion? It is a motion of the object like a ball thrown or launched under gravity with no forces acting on it. Only gravity forces only acting on it. Okay. So there is no air resistance for now. Like you can think of a stone thrown in the air. Yes, it goes like that. But it has two parts. to its motion. It has two parts to its motion. So one is horizontal motion. Another one is vertical motion. Okay. So if you may think about a stone or ball thrown in the air, it has two parts to its motion. Horizontal motion. So this is a horizontal motion. That is vertical. Another one is vertical motion. This is the vertical motion. So horizontal motion. In horizontally, that ball or stone moves with a constant velocity. Okay, in horizontally, that object moves at a constant velocity because nothing pushes it sideways. Okay, that object moves at a constant velocity because nothing pushes that ball or stone in sideways. Okay, right? Only gravitational force only acting on it. Okay. Then next, vertically. So vertically, it accelerated under gravity. So that gravity pulling it downward. Okay. So these are the important notes about the projectile motion. So projectile motion is a motion of the object like a ball thrown in the air. Okay. So there is no air resistance. Only one force is acting on it. That is gravitational force. That is gravity. So if that object thrown in the air, it has two parts. One is horizontal, another one is vertical. In horizontally, there is no force acting on that sideways. So it moves with a constant velocity. Okay. So you may know that. So if one object acting by that force, velocity will change. Okay. So if there is no force, that object will go in that constant velocity. Okay. So that's why I'm writing constant velocity here. And vertically, it accelerated by gravity that is pulling it downwards. Okay. This is clear? Okay, right. So for a projectile launched with the initial speed. In your book, initial speed denoted as V naught. Okay. So for a projectile motion or projectile launched with some initial velocity. So with initial speed or initial velocity V naught here. Okay. So V naught means initial speed or initial velocity at an angle theta naught. So in this case, first one, time of flight. Time of flight. So time of flight means time to hit the ground. Okay. If you throw the ball from here, so that ball goes like here, like this. Okay. And it hits the ground here. So the time taken by the object to hit the ground, that is known as time of flight. Okay. So we can write t equal to 2 b naught sine theta naught by g. So this is the equation for time of flight. 2 v naught sine. So you can put bracket here. 2 v naught sine theta naught g. So v naught means initial speed. Theta naught means initial angle. Okay. So g means acceleration due to gravity. So this is equation for time of flight. So this comes from the vertical motion, where the object goes up and comes back down. Okay. So first of all, that object goes up and comes back down like this. So the time of flight equation comes from the vertical motion. Okay. Okay. Now we can write a range equation for range. So range means horizontal distance covered. Okay. Range means horizontal distance traveled or covered. Okay. Traveled. So we can write that equation for range. So which is denoted as R. V naught square sine 2 theta naught by G. We can put bracket like this. So this is the equation for range. So range means nothing but horizontal. That object travels in a like this parabolic distance, parabolic path. Okay. So the object travels or covered the horizontal distance from the initial point to final hitting point. Okay. So this is a range. V naught square sine 2 theta naught by G. So the range depends on, you can see that there are three quantities there. One is V naught, another one is theta naught, another one is G. Okay. So the range depends upon angle, initial speed, and G. Okay, as result due to gravity. So please remember that range depends upon angle, initial speed. Right. Now we can write equation for maximum heights. Third equation, maximum height. So we can put it H for maximum height. So equation for maximum height, V naught sine theta naught by 2G square, only for this quantity. Okay. So this is the equation for maximum height, V naught sine theta naught whole square by 2G. So maximum height means the peak of the parabola, or the maximum height attained by that object. Okay, the maximum height reached by that object. Okay, right. So these are the important three equations in this projectile motion. Okay, time of flight, range, and maximum height. So any questions so far? Type in the chat box or unmute yourself. So write it down, these three equations: range, time of flight, and maximum height. Okay, okay, right. Okay, let's see this in action. Okay, so to see this in action, we are going to use fit simulation. I want to you pay close attention as I change the initial speed, launch angle. See how the trajectory, range, and the height change. Okay. Okay. I will share a screen now. So now you can see that screen. That is simulation. So you can see the Canon here angle style. You can see that the angle changes like 80 degrees, 55 degree. So you can change the angle, and here you can change the speed. So speed by the speed slider, you can change the speed. Okay. So for example, suppose if I hit the ball or fire the ball. Okay. So just look at that. Okay. So that blue color line denotes the trajectory path. Okay. Right. So here a cannon that launches a projectile. Let's start with a initial speed. For example, we can take 20 meter per second is a initial speed. Okay, like that. Okay. So initial speed V naught here 20 meter per second. Good. And you can take the initial angle as a like for example 30 degree. Okay. Right. So watch what happens when I click fire. Just to look at that. Okay. So see that the curved path. That is the parabola we talked about. Is it clear? Okay. That projectile moves forward horizontally at a constant speed, while gravity pulls it downward. So creating this shape. It's clear? Okay. So now you may have a one question. Sir, how we can we continue to listen to your voice? Please move to your mute mode. Sorry. Okay. Okay. Right. So now we have one question. Sir, how we can imagine that is a speed is a constant velocity. Okay. So for that, just um look at that. Okay. So you may see that two lines. One is the green lines. One is horizontally, another one is vertically. So now look at that. Now look at that. So what did you notice? The horizontal arrow stays the same length, showing constant velocity. Yes, but while the ball moving in that parabolic path, the vertical arrow changes due to gravity. You can now look at that. The horizontal arrow stays the same length, so which is showing constant velocity, but the vertical arrow changes due to gravity. Okay, right. So now you can see that range. So range means already I told you that is the horizontal distance covered and height. So you can okay. For example, for initial speed we can take say 20 and the angle is 30 like that. Okay. Now I click the fire. Okay. Now you can check that height, maximum height. So you can see that time range height. So height 5.1. So here 5.03. Here 4.94 meter. So this is a maximum height 5.1 in this case for the initial speed 20 meter and the initial angle 30 degree. by the equation of maximum height, h is equal to v naught sine theta naught by 2g, the whole square by 2g. So you will get 5.1 like that. Okay. So this is the maximum height of that object in this case. And you can change the angle like that. So now just to click that. Okay. So now just to look at the heights, 11.96 meter, because the angle changes. So now just uh, look at that speed. Okay, you can vary the speed, but at the same angle, 50 degree. So now I click the fire. So just look at that. That's all. So if we change the angle or initial speed, we can change that motion of that ball. Okay, right? So let's try firing again and pause at the peak. For example, 45 degree. You can choose 45 degree like that. Okay, right. Initial speed, for example, 15 meter per second. Okay. Now click that ball. Okay. So 22.9 meter. Okay. This is a maximum range for that angle 45 degree. Okay. So now look at that another one case. Now look at that vertical green arrow and a horizontal green arrow. Okay. So now just look at that. The vertical green arrow length reduced step by step, but horizontal green arrow fixed at the constant length. So which denotes a constant speed. Yes. So at this point, the vertical speed is 0. So there is no vertical line. Yes. So at this point, the vertical speed is 0, but the horizontal speed stays constant. Okay. So these are all for projectile motion. You can change the object like here. You can change the cannonball, tank cell, or pumpkin, human like that. You can change the angle or you can change the speed. Okay, whatever else. But that projectile motion, like for a speed, range, time of flight, maximum height, you can see that in all the three equations, there is no m. Yeah. For example, in the maximum height equations, uh, v naught sine theta naught by 2g. There is no m. And the time of flight, 2v naught sine theta by g. There is no m. And for range equation, v naught square sine 2 theta naught by g. There is no mass. So, projectile motion does depend on, not depend upon mass of the projectile or mass of the object. Okay. So note that point. It does not depend upon mass of the object. It depends upon the initial speed. It depends upon the angle and like okay. So and as well as acceleration due to gravity. Okay, but it does not depend on the mass of the object. Is it clear? Okay. So this is a simulation for yeah, to imagine that projectile motion. Okay, you can change the speed, you can change the angle and see the parabolic path and horizontal motion and vertical motion. Okay, right? So this is and as well as in 45 degree, you can see that angle 45 degree, it gives a maximum range. Okay, Right. So this is exactly what happens in real life. Like think of a basketball shot. Yes, the ball follows a parabola. The basketball follows a parabola to the hoop or artillery cells in history. They were aimed using these equations. Okay, the horizontal and vertical motion are independent. Okay, horizontal motion and vertical motions are independent. So, which is why we can predict the path so precisely. Okay, right. Any real life example you can think of? Type them in the chat box, or you can unmute yourself. Any real life example you can think of, like here in history, art results, and in sports, you can see that the path traveled by the basketball, that is parabola, like that, right? Any other real life examples? If you know the any other example, you can chat in the box. Okay, right. So let's solve two problems on the whiteboard to practice these equations. Okay, right. Problem number 1. So question, a ball is projected, at 30° with a speed of 20 meter per second. Find the time of flight. Find the time of flight and range. So we can take G as a 10 meter per second square for simplicity. Okay. So if you know the answer, if you have the answer, you can tell them, tell via the chat box, or you can unmute yourself. A ball is projected at a 30° with a speed of 20 meter per second. Then what is a time of flight and range? Anyone? Cricket is one example. Yes, very good. Real life example of parabolic motion. Good, super. What is the answer? Time of flight and range. Okay, right. So time of flight. Already we know that equations T is equal to 2 into V naught sine theta naught by G. Is it correct? Okay. So here V naught is denoted as initial speed. So 2 into initial speed V naught here with a speed of 20 meter per second. So we can put 20 here like that. Okay. And sine theta naught means initial angle. So here you can see that 30 degrees is the initial angle. So we can put 30 degree here by G. So we can take a 10, taken as 10, okay? So 2 into 20 sine 30. Already you know that sine 30. Yes. So I can put 0.5 here and 10 like this. So now what is the answer? Yes, 2 seconds. Yes, time of flights. So 2 seconds. So 20 into zero point 0.5, 10, 10 by 10 cancel out and 2. So 2 seconds. Time of flight 2 seconds. Very good. 2 seconds. Very good. Oh, okay. 2 meter per 2. Okay. 2 seconds. Okay. Time of flight 2 seconds. Okay. Next case range. Next case range. Already we know that the formula for equations, sorry, range V naught square sine 2 theta naught by G. Yes. So now we can put that value here. For example, V naught square 20 square. Yes. Sine 2 theta 30 degree by 10. Yes. Okay. What is the answer? 3.4, 34. Okay. 3.4 or 34? 3.4 or 34? What is the answer for range? So V naught square 20 square sine 60 degree. So sine 60 approximately we can take as a value as a 0.866. Okay. So 20 square means 400. 400 into 0.8666 by 10. Yes. For example, 400 sine 60. Okay. So sine 60 approximately 0.866 by 10. So we will get 34.64 meters. So for because range is nothing but distance covered. So that's why. So here the unit meter 34.64. Correct. Very good. One well done. 34, 34. Yes, yes. Correct. Very good. Super. Great. Situr, GJC. Great. Okay. Now we can move into the another one, sum. Okay. Right. So problem number 2. A cricket ball, a cricket ball is hit horizontally from a height of 2 meter with a speed 10 meter per second find the time to hit the ground and horizontal distance. Okay. So a cricket ball is horizontally from a horizontal from a height of 2 meter with a speed of 10 meter per second. Find the time to hit the ground. That is also known as time of flight. Yes. And another one is horizontal distance. That is known as range. Is it clear? Okay. So you can see that horizontally. So horizontally means horizontal for a horizontal launch, we can take theta naught is 0 degree. Yes. So horizontal means the angle 0 degree. So we use vertical motion to find time. For a horizontal motion, for a horizontal launch, theta naught is equal to 0 degree. So we can use vertical motion to find time. Okay. So already we know that one formula from equation of motion, that is S is equal to uxt plus half at square. Yeah. Okay. So here S is equal to distance. So distance 2 meter. Ux means initial speed, but here initial speed 0. Okay. Because initial vertical velocity is 0. So 0 meter per second. A or G equal to, we can take it as a 10 meter per second square. So S is equal to, so yes, 2 meter, Ux 0. So 0 into anything 0. So half A 10 T, which is time. Yes. So 2 equal to 1 by 2 into 10 into T square, which gives, so 2 goes here and 2 into 2, 4 and 10 goes here. So 4 by 10, 0.4. So we will get T square equal to 0.4. So T equal to, we have to take roots. Yes. Root of 0.4, which gives approximately 0.63 seconds. So which is the value for that time to hit the ground? Only 0.63 second in this case, for the horizontal motion with a height of 2 meter with a speed of 10 meter per second. Okay. So S is equal to ux plus half at square. For the initial vertical velocity, that object has a initial speed 0 meter per second. So ux is equal to 0 and S is equal to 2 meter. A is equal to 10 meter per second square. So which gives T is equal to 0.63 second. Now we will go into that horizontal distance, that is range. So we have only initial speed and time, right? Horizontal distance. So in this case, horizontal distance, that is range, which is denoted as, so range means displacement. Already you know that displacement equal to velocity into time. So velocity means the cricket ball is horizontal with a height of 2 meter with a speed of 10 meter. So that 10 meter is a initial speed here. Okay. Horizontal speed. Vertical speed 0, but horizontal speed 10. So we have to put here horizontal speed. So that is V naught into T. So R is equal to V naught 10 as per the sum into time. Already we have that is 0.63, right? So which gives approximately 6.3 meters, which is the value of horizontal distance. Okay. Any questions on this? So just try that like this sum in your home. Okay. Okay. All right. Okay. Very good. Let's test your understanding with this topic with one quiz. Okay. I will share the screen. Okay. Right. If a projectile is launched with a speed of 10 meter at 60 degree, what is the time of flight? We can take G as a 10 meter per second square. So here you have speed and angle, initial speed, that is V naught and angle theta naught. Okay. What is the value of time of flight? 2 seconds, 0.5 seconds, 1 second, 1.73 second. If you know the answer, please type in the chat box. Just to put those values in the equation of time of flights. Already you know that formula of time of flights. 2 into V naught sin theta naught by G. Just put that V naught 10. Okay, already one response. Answer B, 0.5 seconds. 2 into V naught. V naught here 10 sin theta naught. Sin 60 degree by G. So G here 10. So 2 into 10 into sin 60 by 10. What is the value? 2 seconds or 0.5 seconds, 1 second, 1.73 second. Okay, another one response. Okay, very good. Super. Government Junior College, NR Pita. Very good. Super. So answer is 1.73 seconds. Yes. So 2 into 10 into sine 60 by 10. We can cancel out the 2 by 10 is a 1 by 5. 10 sine 60, which gives root 3 by 2. So in the final, we can take that value of root 3, 1.732. So we can take it as 1.73. Very good. Another one, GJC Penuma. Okay, good, good, super. Right. So fourth option. Yes, correct. One second. I will share another one. Right? Okay, wait a second. Okay. Right. APMS 33. Okay, very good. Super. Good. Okay. Another one question. What is a safe? Very, very easy question. Yes. What is the safe of the projectile's trajectory? Neglecting air resistance. So that path may be hyperbolic or parabolic, circular or linear. Which option correct? Very good. Very quick response. Very good. Two. Ah, yes, correct. Very good. Any other response? Any other response? Okay, another one response. Yes, APMS. Oh, very good. Krishnaveni, Government Junior College. Very good, very good. Super, super. Yes. Parabolic path. Okay, we can choose. Good. Right. Another one, very, very important one word. Which factor does not affect the range of a projectile? Which factor does not affect the range of projectile? Mass of the projectile, gravity, initial speed, launch angle. Another one, very easy and super question. I think so. Quick, quick response. Which factor does not affect the range of projectile? You can think about the formula for range. Already I told you in that class. Yes? Yeah, very good, very good. Government Junior College, NR Peter, Carrots, 4, GGG, Moss. Ah, yeah, very good. Parvatipuram, very good, super. So 4 are some 4, Moss. Yes, yes, Moss. Okay, 1, 1. Very good, super. Yes, great, great, great. So the mass of the project is the correct answer. So the range of the project does not depend on the mass of the, because in our range equation there is no m, there is no mass, but it includes gravity, initial speed, launch angle. Okay, so you can choose yes, one. Is the answer, mass of the projectile. Good. So this sum already we okay 1.73 second. Okay, right. Fourth question. For maximum range, at what angle should a projectile be launched? Already I told you in that class. For a maximum range, at what angle should a projectile be launched? 30 degree, 45 degree. Yeah, response times. Very good, very good. MS, MN, GGC girls. Yes, yes. Parvatipuram, Government College boys. Krishnaveni. Yes. Good, very good. Super. So 45 degree is the correct answer. It's a right angle. Okay. So in that angle 45 degree, that projectile or that object or ball, okay, it attains a maximum range. Okay, 45 degrees is the answer. Good. Okay. And final one question. What is the vertical component of the velocity at the highest point of the projectile path? Just to look at that question. What is the vertical component? Already I told you there are two components of velocity. Yes, already one response. 0. Government Junior College, NR Beta. Very good. 0. Super. Krishnaveni GJ 404 Junior College Boys. Yes. MS1 GJ College 4. Yes, correct. Already told in the class. Yes. So at the highest point, at the maximum height, vertical, there are two components. Already told you that is vertical component, horizontal component. Horizontal component does not change throughout the motion. Very good. MS1 GJ girls. Sittur, GGG. Yes, very good. Good. So, vertical component of the velocity, 0. Good. Correct. Very good. Very nice. Awesome. Okay. So, now I have love to hear from you. Can 2, 3 students explain in your own words what projectile motion is? Or share a real life example, like in sports or movies or in games, like that. Okay. You can tell about you in your own words about that projectile motion or a real life example of the projectile motion. Any other examples? Any other comments? Okay, okay, good. Okay, right. So let's wrap up. Today we learned that projectile motion involves two independent motions. One is horizontal motion. So two independent motion. One is horizontal motion, that is constant velocity. Already told you. Another one is vertical motion, that is accelerated by the gravity. We have three equations for this projectile motion, and that is one is time of flight, range, and the maximum height. Okay, right. For homework, please write it down for our homework. Okay, first one, calculate the range and maximum height for a projectile. Okay, at 45° with an initial speed of 15 meter per second. You can take G as a 10 meter per second square. This is the first system. Just note it down. This is your. I will write another one problem now. Okay. So calculate the range, maximum height for a projectile that is launched at a 45°. Already you know that at a 45°, it attains a maximum range. Yes. With the initial speed of 15 meter per second. Okay. Next one. Right. 5 sentences describing real life example of projectile motion. Like in sports, in nature, or in technology. Okay. So for your homework, first one, calculate the range and the maximum height of that projectile launched at a 45° with an initial speed of 15 meter per second. Assume G is equal to 10 meter per second square. For the second question, write 3 to 5 sentences describing a real life example of projectile motion. You can take it in the from sports, in from nature, or from technology. Just to write it down. Okay. All right. So again, I will write that three important equations now for your reference, for your understanding. Okay. So time of flight, V naught sine theta naught by G. This is the equation for time of flight. The next one, range of projectile, R V naught square sine 2 theta naught by G. Okay. For the third one, maximum heights. Okay. So H equal to V naught sine theta naught the whole square by 2g. These are the important equations in this topic. Okay. Rainbow range 2.25, very good. Well, responses, good. So these are all today, class. Okay, any other questions? Any other questions? Any other doubts? If you have any doubts, you can unmute yourself or you can chat in the box. Okay. Okay, no doubt. Okay. Thanks. Thank you so much. Thank you, teachers, and thank you, students also. Very happy today. So, well done. Good. Keep it up. We will see in the next class. Thanks. Jai Hind, Jai Bharat, Jai Vidyasakti.